So listen, if you want to do serious circuit board soldering, you want precise control over how much heat you use and where that heat goes. That means you need a soldering station like the Metcal GT120. Why? Because it heats your soldering tip to the right temperature quickly, it holds that temperature exactly, and it quickly recovers to that temperature after transferring heat into your workpiece. Oh, you want one? Well, you're in luck because Technitool is giving away a Metcal GT120 and it's signed by Mythbusters alum Tori Belici. Right. So if you want one, go check out Tori's GT120 unboxing video first and then enter to win. You can enter at www.techni-tool.com/Metcal-giveaway. And I'll put that all on the screen for you because there's no way you're going to remember to type that all in. And we're going to put a link in there because you want easy access to win that Metcal, don't you? So get going. All right, I'm Nicolette, and today Brian and I are here with Ben Waters. We are back with Ben Waters, I should say. He is the CEO and co-founder of Wibotic, and he is here this time to talk to us about robotics empowering robots in space. So last time we focused a lot on industrial related robots, and now we're going to have some fun with some space related talk. So thank you again for joining us, Ben. We really appreciate your time again.
Thanks for having me.
All right. So before we left off last time, you kind of alluded to the fact that there's a whole lot going on in space-related technology, and I mean, obviously,
while Brian was interrupting and just asking questions about robots on Earth.
Yeah, let's go somewhere else.
Topic, but
yes.
So, I mean, my biggest question is obviously going to be, how do we power those robots in space? So obviously this whole conversation is going to be about that. But, do you want to tell us a little bit about what Wibotic is doing in that realm?
For sure. Well, as has been very visible in the news over the last, decade, if not more, robots in space has been something that's been happening and is going to continue to happen. We've all seen the launches to Mars in recent years and heard about the successes of the Mars rovers that have been going on. The past 5 years, NASA's had a big focus on getting back to the moon. There's a program called Artemis, which is NASA's effort to really deploy robots, people, infrastructure back onto the moon, really starting next 2 years and continuing, throughout the 2020s. And it's an exciting time. There's massive opportunities for small businesses, startups to partner with NASA, work with larger companies who have been launching things into space for a long time. There's a growing number of different types of robots to do different tasks on the moon, everything from just your general surface inspection to robots that can dig and collect samples, all in efforts to learn more about what life beyond Earth looks like, or could look like. So exciting times.
So, okay, I have a question. Now you're talking about the moon, right? We see a lot of focus on Mars recently. Do you think, is there a lot more focus going on the moon because it may be a jump off point?
Yeah, I don't pretend to know what happens behind the scenes, but I think it's apparent that there are different cycles within NASA that focus on different things. 10 years ago, a lot of the research was focused on Mars, and we're seeing that deployed now. This current set of 10 years that we're in, tends to be a lot more focused on the moon. So I think in a few years, when a lot of that development work starts to become done and deployed, we'll start to hear a lot more about things going back to the moon. Mars and the moon both have different and unique challenges. Mars is a lot farther away, and getting things there is very expensive and very challenging. And as we saw very publicly, just landing on the moon landing on Mars with a robotic system is, quite an accomplishment in and of itself. So I think the moon's a little bit more accessible. It has its own challenges with respect to, temperature and environment and all those things. But I think the effort is just focused on the moon more in recent years.
So, well, can we talk about what they're currently? So, the robots on Mars, how are they currently powered? What is the current solution, and are there some challenges that arise there?
Yeah, definitely. So, pretty much all of the things in space today are powered by a combination of batteries, solar panels, and fuel. For them to get up into space, they have fuel, but typically once they're there, all the electronics and everything, it's all solar powered. And that typically works great for things like satellites, things that aren't subjected to dust, or things that aren't, on the surface of a planet. But once you get onto the surface of a planet, that's where those ways that things are powered start to become very, very challenging and problematic. I think we talked last time about the fact that the prior Mars rover, there was a huge dust storm on Mars. It caused the solar panels to become covered for a few days and not be able to get enough power to the robot. The robot even had the ability to try to, clean itself off or wipe the panels. But the storm sustained for a long enough period of time where the battery died. Panels never came back online to charge the battery. It got cold, and then that, without the heater being able to turn on the robot, froze it. So that took quite a number of years. That robot lasted for a lot longer than at least what I read NASA had projected it to, which is impressive and awesome. But I think the point is, eventually something like that can and likely will happen. So the question becomes, is there something you can do about it to ensure that there's going to be longer operating times of these things? Because at least for today, once something like that happens, there's no getting it back. It's done. So yeah, there's a lot of challenges with that. But traditionally, batteries and solar is the way it works.
So maybe there are already, but do you think there's also going to be eventually charging stations that are now powered, so outside of the robot? So you have the one on the robot itself or on the rover, but also stations around where they get charged. That way, that's always charging. It's not necessarily subject to where the robot is in that time and place.
For sure. I think one example that's demonstrating that NASA's thinking about this is there's an initiative called Watts on the Moon. It's a program that offers grant funding to companies. Wibotic didn't actually participate in that program. We just heard about it. It's related to how you get power on the moon and how you distribute it around the moon. So there's a lot of proposals that have large solar panels that can harvest a lot of energy, and then just like we're doing on Earth, you can store it in a big battery bank, and then you can have infrastructure that can distribute it to different places throughout the moon. So totally, I think an electrical grid of sorts is definitely something that is being thought about. Probably will be sometime before it's fully deployed in effect, but there's all the smart companies of the world thinking about the right ways to solve those problems, and solar panels are part of it. Fuel cells is part of it. There's probably even some talk about, small nuclear power systems that can sustain energy for a long period of time. What's going to win, I don't know, but I think all of those topics are on the table and being explored through programs like Watts on the Moon.
Well, what about Wibotic's wireless charging systems for the moon rovers? Now, that's something different than powering on the moon. These are for the rovers once they get there, correct?
Yep. Yeah. So where we're very excited about the moon is to avoid this problem of the solar panels being a point of failure, to avoid the problem of the fact that during the night, solar panels aren't going to be harvesting any energy, and the lunar night is 14 Earth days long. So it's a lot longer period of time that a robot would have to operate or figure out a way to get power. And dust, especially on the moon, called regolith, space dust on the moon, is very tricky and harsh on electronics. It tends to be more conductive than dust on Earth, and it's very fine. And because of the gravity situation on the moon, it tends to just get in to a lot of places that you wouldn't expect, and it can cause a lot of havoc with respect to electronics and other things. So where wireless charging comes in is really looking at how to make these charging systems reliable and last. So we are excited to be part of a partnership with Astrobotic and Bosch and the University of Washington on a tipping point proposal. It's the name of the grant that our team was awarded. Astrobotic is the prime contractor, and they're developing a small robot called the Cube Rover, and they're also developing a lunar lander for which the Cube Rover would get deployed from once it lands on the moon. And the concept is that the Cube Rover would be able to drive back to the lunar lander and wirelessly charge itself, so that it could operate during the lunar night if solar panels aren't there. The lander would have enough battery storage to be able to charge the Cube Rover during the lunar night. And NASA and anyone would be able to use that robot to explore at times that we've really never been able to explore because they've always been powered by solar and they haven't had enough power to run when the sun goes down.
And that's a good point too. Like, space has always been limited. Like, if you can't get into certain places, as we don't have day and night the way we have day and night, where now you're going to be able to explore a whole bunch of new areas of the moon or wherever, right? Because you could actually do it where there's no solar, where there's no power, And do you think also too, like the technology getting smarter, like the robots being able to know, like, okay, I need to head back home, to get powered, is going to play a huge part of this?
Yeah, I think so. I think the moon is just going to amplify those challenges. I mean, companies, as we've worked with a lot of them on Earth in warehouses, the warehouse is nice and flat. Yes, it has obstacles that are coming and going, but the moon, very rugged, changing. Temperature range is so extreme. When the sun goes down, it gets absurdly cold, and when the sun comes up, it's extremely hot, and that presents a huge challenge for electronics and mechanical systems in general. So you've got all these things, in addition to the fact that it's on the moon and no one can really go service it if something does go wrong, at least not easily. So I think it's an amazing opportunity for robotics and automation and power and charging and all these things to really prove how well they can stand the test of these challenges and environments. And if they can do it there, then we'll be able to do it pretty well on Earth, I think.
Yeah, and you brought up a good point too, because a lot of people don't think about this, especially if you're reliant on like a battery array. The temperature actually plays so much into how long that battery could last, right? People don't realize, like, a lot of cars, their batteries go dead in the middle of summer because of the heat, so, and having such a wide variety of temperature, plays a huge part into what that robot needs to do in order to figure out when it needs to charge also.
Yeah, absolutely. And it's not like there's a plethora of batteries out there that are designed to survive the temperature range on the moon. So if we had done some research, and this is all public, you can look at like block diagrams of the Mars helicopter. Amazing engineering. The body of that helicopter, where the circuitry are, the motor controllers are, has a heater, and it's insulated. because the electronics in the battery weren't designed to withstand, the extreme cold on Mars and on the way to Mars and all those things. So now you're thinking, we already know the challenges of drones and how limited the battery life is on a drone, right? Like it can only fly for 20 minutes or whatever. Now you've got that battery also having to power a heater, which consumes a lot of power to turn on. And you're putting a heater inside a drone, which is extremely weight sensitive. So that's one of the reasons why that helicopter, only flies for a few minutes. When I first saw that, I was like, I wonder why I can only fly for a few minutes. Well, there's the heater element, there's that battery element, and then there's the fact that the atmosphere is so much thinner than here on Earth. So the propellers have to spin, multiple times faster than they do on Earth to get the needed lift. So just amazing, how cool that is, I think. And it's an example of the fact that sometimes you don't just go buy the space qualified components. Sometimes you have to really think out of the box and engineer, how do we get a heater in this thing? How do we, survive against a 6-month journey where there's massive shock and vibration requirements just when the rocket launches? These are all part of the challenge of operating in space, and you got to get there, and then you got to be able to just survive, let alone, actually work and operate when the time comes.
So then, we're talking about, you mentioned components for, space applications. What would you say to engineers who are designing these components that are typically used in these types of applications? What would you tell them to be thinking about most importantly?
Yeah, it's funny, at Wibotic, we've focused on some designs for maritime, underwater applications. We've focused on some designs for now space. We focused on some designs that are very cost sensitive, high volume robotics automation that price is something that needs to be very strongly considered. And engineers, I think, have different levels of experience in those things. Some engineers have spent their whole careers focusing on how to design circuits for underwater operation. And there's some very specific, very unique things that you need to consider there. The pressure that electronics can be exposed to at depth underwater is very extreme. Components can literally crack. And you have to do things like consider how to put little pads beneath large components like resistors so they don't crack under that pressure. So my point is, I think it's so interesting how these different applications require very different backgrounds and knowledge around what to do from I guess I'm talking mostly from an electrical engineering perspective. That's my natural space. That's my background. But I think, what I would say to engineers is I think there's so much value in having that diverse set of knowledge. It's amazing when you find someone who just knows how to do one thing. I think it's also beneficial to the team, working on these different things, to have folks that have, diverse sets of knowledge. So my biggest recommendation is, always think outside of the box. Here's one example, right? So when it comes to designing for these extreme temperature environments, right? One approach, you can just go buy the world's most expensive components that have the widest temperature range that you can find on the market, and they might just work. Another approach is you could use, let's say, more, traditional components with more normal temperature ranges, and then think about how to do a heater. You could think way outside the box and have a robotic arm that can move the position of the electronics so that when the sun's shining, it's in the shade, and when the sun's down, it's close to something that naturally is generating heat. Like, there's so many ways you can solve these problems, but if you're if you've only had experience kind of focusing on, one thing like designing for high temperature components, you might only think to start with that first one, and
Right.
I think that's what NASA's inspiring. They're forcing the industry to come up with a lot of these creative solutions. Infrastructure companies like Wibotic, if we can provide power systems that work on the moon, it's going to be a lot easier for companies trying to build and deploy robots to build their robots that will work well on the moon. So
it's one less barrier then,
Yeah.
if they don't have to worry about the power, then they can really get creative too.
absolutely.
Well, and to your point, I mean, it seems like Wibotics falls into that last scenario you made with what you're doing, what you're doing on the moon currently, Now, I do have a question. So we talked about the smaller robots, and I'm sorry, I forgot the name of them, and then sort of like that power hub that it's going to go back to. Is that also generating power, right? So you have your battery arrays that are going to launch with it. Is it also generating power through like solar and other means, and even maybe like regenerative power or any other forms of power?
Yeah, at least within the work we're doing, that's not a part that we're looking at. But what I've seen is that for sure the landers or the hubs that will act as power sources will likely have a combination of ways that they can generate energy. Solar, probably the most obvious. Having big battery banks that can hold that energy for long periods of time. There definitely are some companies who are looking at long range wireless charging. Most of them are, public and looking at both commercial applications as well as some of these government applications. And so, I think I think you'll see a lot of different things. I think you have to, because if you're just relying, for example, on solar, and we know that from experience these panels can have challenges and over time break. Well, if that happens to your power grid and the whole power grid goes down, then everything else is going to be, and there's things relying on that power grid, it's just going to be a cascading effect. So I think it's going to take the combination of things, fuel cells and nuclear and solar and all these things that we've thought about for ways to power things here on Earth, I think are in play. Just becomes a question of, what makes sense, what can handle the elements, what's cost effective to deploy, because it's expensive to send stuff up there. So I'm no expert. I just, think it's a really cool space, and it's going to be fun to watch how it all unfolds here in the next 5 years as stuff's really going to start getting launched and being deployed on the moon.
Right. So you mentioned long-range wireless charging, right? What do you think is going to really propel that? Do you think it's going to be space? Do you think it's going to be like, electric cars or autonomous vehicles or things like that on Earth? What do you think is going to be the big pusher? Because people have talked about wireless power for a long time, and that range has always been the thing.
Yeah, definitely. I mean, I remember in grad school, there was a lot of publications and articles being written by different researchers around the country and around the world, looking at ways to charge your EV while it's driving down the highway. Totally makes sense, but challenging. The power level that you need to not only charge the battery, but if you're assuming the car's driving, you've got to be sending enough power to power the car, right? And then enough power on top of that to actually charge the battery. So, there's all these unique challenges with wireless charging and charging things as they're moving and as they're operating. And then there's a number of different ways you can do it. I've heard about lasers being used. The nice thing about lasers is they can be very efficient. They can travel long distances, and you naturally will always have this sort of flashlight telescoping effect where it tends to get broader, but there have been demonstrations where companies have shown that you can generate solar energy in space and beam it down to Earth. And you got to consider things like safety and how all that works, but a lot of those things have all been thought through. Whether that becomes a viable thing, to be determined. But I've seen the technology, and I think it's possible. So a number of different ways you can do things. I think it just as we've thought through at Wibotic, there's always trade-offs. Nothing's ever like the perfect solution that's a win-win-win in terms of efficiency, cost, reliability, all these things. So I wish I had a better answer for what I think is going to win. I'm just excited to sit back and watch wireless charging become a very useful technology, hopefully for a lot of applications here on Earth and in space.
So originally I was going to ask you to leave us with something really futuristic, right? But then I started thinking as I was sitting here, my engineer friends on Reddit, they don't like when we talk about futuristic stuff. They want practical. So I'm gonna ask you a practical question. At the rate that we are progressing with wireless power and all kinds of power solutions in space, where could we be if we kept progressing at this rate? Where could we be in 10, 20 years?
Yeah, it's a good question. I remember the last time we talked, Brian, we were chatting a lot about just consumer battery charging in general.
Mm-hmm.
How many battery powered devices are you gonna have in your home and have to deal with? I actually saw a LinkedIn post from someone where they literally asked this question. They were like, type in the comments how many battery powered devices you have in your home, and then put in parentheses how many of those are lithium ion, like rechargeable batteries, not just like AA batteries or something.
Right.
And it was staggering. It was like in the 30s, like for most people that I saw. And that's just a lot of things to always think about managing and charging. So, Nicolette, to your question, I think it's happening today, and there's standards being developed, and there's still technical challenges and regulatory challenges. But I think the idea of just your cell phone and your headphones just will sort of naturally be charging throughout the day is possible. There's a lot of infrastructure that needs to be set up to do that. And there's a lot of, safety hurdles that society has to overcome to accept that. But, in the same way that 5G adds more energy at higher frequencies and more bandwidth to our space, it happened, right? So I think that's within the realm of possibility. So phone's in your pocket, you're just walking around, and it's just sort of keeping itself topped off all day. That technology's being developed, and I think for low power devices, even the phone's probably pushing the power level that I'm talking about here. But for more wearables and IoT stuff, I think that's practical. That's not necessarily something that we're developing here at Wibotic, but that's something that I think has a clear technical and user friendly jump, like a step function above the way we deal with charging now. I'm in a hotel right now, and we got 5 USB cables over there. It's craziness. So I think that would be a jump that would really elevate things. I think that for EVs, I think what's going to really be a catalyst for EVs, is having a diversity of charging options, right? I think there has to be fast chargers so that you can you can just plug your EV in, and in the same way that we're used to going to a gas station for 5 minutes and filling up the car, you get enough to do it. Even right now, you got to go to like a curbside charging stand and wait for maybe 30 minutes, and that's starting to be long for folks. So I think if that exists, that's going to be awesome. And then wireless charging for EVs has a lot of advantages. I think too. Maybe not all use cases for wireless charging, but parking lots at work, right? If the spot just has a pad under it, you just pull in, car charges up over the course of your workday. free, great. You know, autonomous self-driving cars. You know, the ability for them to just pull into a spot, wait and charge, and then when they get hailed as a self-driving taxi or hailed as a self-driving delivery vehicle for, you know, Amazon delivering packages, right? I think all that stuff adds a lot to, you know, efficiencies and cost savings and user friendliness. So I think I'll talk about those two industries. You know, I think those two things help. And then, you know, where Wibotic's really focused is on the industrial automation side of things. And we think that wireless charging has some major advantages when you talk about big fleets of autonomous things. Because if you use contacts or plugs, the reality is they will need to be replaced at some point. And if the goal of companies in automation is to scale up and have things be hands-off, low maintenance, reliable, you're designing in something that you know is going to need to be serviced and fixed. That's why we're so bullish on, you know, wireless charging for the automation industry, and that's why we're excited about sort of staying within those lanes ourselves. But those are some of the other areas that I think have good practicality, and there's still challenges, still a little futuristic in some of those things. But I think companies are working on it, and it'll be fun to see.
Okay, I have one more question. I know Nicolette was probably, you know, going to her last question, but
nope, that was my last one. But I think I know where you're going. So
no. So here's the thing, right? In two contexts, we talk about sort of fleets of fleets, meaning like you're going to have this vehicle or this charging station that's going to get to a place and deploy a fleet of rovers, right? We see that also in delivery systems where you have a big truck that's now deploying smaller robots to do delivery. Is that one of those things where we're going to see like the wireless charging going in the bigger vehicle that's holding the smaller vehicles to charge? Is that, you know, it seems like that's really something that's becoming very practical because if you think about it in a warehouse solution, it's sort of the same thing. The warehouse is that thing that's holding the fleet of robots, and they're coming in and charging. So it's almost like this mothership. I don't know what else to call it, where they're coming back to you to charge.
Yeah, I think you're spot on. I had a funny encounter that sort of, I'll just tell this story, and it emphasizes, I think, this point. So I was at 7-Eleven, and it was like late at night. This was actually on a work trip. I was coming back to the hotel, and there was a delivery truck outside of 7-Eleven, and the truck driver was bringing boxes and stuff in to put stuff in the store. And I saw he had an electric pallet jack, which you know, there's a battery in it. You can, you know, just push a button and it'll lift up the pallet, and he was using this, but he was manually cranking it. And I just was so curious. Because we've thought about this same idea. And I said, so I went up to him and I asked him, I said, why, you know, aren't you using the electric pallet jack? Why are you cranking it manually?
Right, I would ask the same thing.
and I just, and he said, he went, well, you know, it's not, the battery's dead. And so I said, interesting. You know, why is the battery dead? And he said, well, you know, the way the operation works is typically, you know, I don't get the same truck every day. Like, I show up in the morning, I get whatever truck, you know, I'm assigned. And if the driver the night before didn't plug in the pallet jack, I'm without the pallet jack all day. And I have to work till 11 o'clock because it takes me, you know, so many more hours to plug in or to operate these things manually. And I was just, I was like, wow, you know, I get excited about, you know, cool opportunities for battery charging. And so that was an example where I think if you consider the scenario where trucks, sheds, whatever might be a host for these battery powered devices, whether it's delivery robots or whether it's pallet jacks or, you know, whether it's power tools or whatever, just imagine you've got a little charging bay right there in the back of every truck, and whatever happens to be sitting there, you don't even have to worry about plugging in, and it's charging. There's plenty of power, plenty of batteries, or plenty of fuel to power these things. The trucks are almost always just like left on, right. When they're doing deliveries. So, yeah, totally agreed. And I thought that story, would justify that.
Yes.
It's definitely something that we're interested. And if there's anyone out there that's experienced this problem, definitely reach out to us.
All right, ask him your last question. Ask him your favorite question. I mean, we've been talking about.
Oh God, we ask when we're getting to Mars. When are we getting to Mars, Ben? When do you think we're going to be on Mars? People.
That's a good question. I think we should schedule a follow-up call with who's been, in this industry for a lot longer than Wibotic has, and they'd probably have some really good perspective on that.
Wild guess.
I know.
Wild guess, yeah. Wild guess, Ben.
Yeah, I know for the moon, that they're looking at 2024, 2025, and the years after that to have, the robotic missions go up, and in that same timeline have human missions go up, and build vehicles that can drive humans around on the moon. On Mars, I guess my best guess would be 2030.
Okay.
All right.
Okay.
We're gonna find you in about 9 years and let you know if you're right.
That's right.
I hope I'm wrong. I hope it's sooner. I know that there's a lot of emphasis on the moon, and we'll see if a lot of that happens before things get going to Mars. But I very well could be proven wrong, and I hope I am, because that'd be pretty cool.
But you're a practical guy, so you got to think practically.
And I'm with you. Ben. I think in the 2030s sometime, is when we'll really get there.
Well, Ben, we really appreciate you coming back to talk to us all about space and power. So we do appreciate that. Thank you so much. And please, once again, let everybody know where they can learn more about you and Wibotic Solutions.
Sounds good. We are at wibotic.com. We post a lot of our news and updates on LinkedIn. You can also find us on Twitter, and feel free to reach out to us anytime on your website. We love talking to folks interested in battery charging, folks who have thought about unique ways that wireless charging can be useful and is needed. Yeah, that's been a motivation for me and for Wibotic, is following the applications that have a need for better modes of charging and wireless charging.
At a pro baseball game, when a hometown hero hits a grand slam, a lucky fan ends up with an autographed bat. Why not celebrate that same passion in electronics? Technitool is giving away a top-of-the-line Metcal GT120 soldering station signed by Mythbusters alum Tori Belleci. Unlike autographed sports gear, you won't want to leave it in a display case. Check out Tori's GT120 unboxing video. Go to technitool.com/Metcal giveaway and enter for a chance to win. We'll also drop the link where you're watching this or listening to this below.